Hello, beautiful people. Today we're talking about 6.3 confidence intervals for population proportions. We have SWABATs today. It's part 1, find a point of estimate for population proportion. Part 2, construct and interpret confidence intervals for population proportions, and determine the minimum sample size required when estimating a population proportion. So first thing, or the only really new thing here, is the point estimate for population P. So you have a population, and the probability of success in a single trial of a binomial experiment is denoted by P, the probability of success. You've seen this before. It's when you only have 2 possible outcomes, and the percent of success we're going to denote as P still. The point of estimate for P, that's the new part of this, is similar to what you've done before, except instead of the whole total population, you're going to have the number of successes in the sample divided by the number in the sample. So the same way that you would normally get a proportion or a percent is the same way that we're going to get it here for the population sample, or for the sample, excuse me. So it's the number of successes in the sample over the number of successes. Sorry, the number in the sample. So we are going to read this as P hat. P hat. That's how that's said. And then the next portion of this is for the proportion of failures. So that's the Q. We've seen that before, and that's Q hat equals 1 minus P. So if you can only have this or that, and the proportion for success is P, and then Q is just going to be 1 minus that, because it's the remaining portion of that. So the next thing is confidence intervals for P. This is how we'll construct it now. We're using P hats instead, plus and minus the error, as you've seen before, and then we're going to be using this formula as well. What I'm going to end up doing is talking you through a longer example, and then in your homework you'll have to do just parts of this for most problems, and then all of it for others. So let's just kind of get into this. Okay, go ahead, take 1 minute and press pause, and I'd like for you to read this first example and highlight what you think is important. After that, I'd like for you to do step 1, which says to identify the sample statistics, the N and the X. Recalling this, I'm going to tell you now, N is the number in your sample, so N, that's the number in your sample, and X is the number of successes. So this is the number in the sample, and then this is the number of successes. So go ahead, read your problem, highlight, and then identify. Okay, did you do what I did? The survey of 1,000 US adults, 662 said that it's acceptable, and 95% confidence intervals. So identifying things for number 1, if N is the number in the sample, well, they said that we did 1,000, so hopefully we agree there. And then X is the number of successes, so 662 said that it's acceptable to check your personal email at work. I don't know if Miss Riley is part of this survey, so I'm going to not check mine. Step 2, find the point of estimate. So for your point of estimate, you're going to go back to that formula that you had up in the beginning, which said that P hat is equal to X over N. So the successes, which was 662, over the total number of people in that sample, which was 1,000. And then this will equal 0.662. Okay, step 3. So there's going to be some homework problems where all you have to do is step 1. No, I'm just kidding. All you have to do is step 2, find the point of estimate P. Now you know how to do that. Now, for step 3, they would like to verify the sampling distribution of P hat. We want to verify that that can be used to approximate a normal distribution. So in order to do this, you've kind of done before, it's N times P hat instead of N times P. That has to be greater than 5, and N times Q hat has to also be greater than 5. So for the first part, the N was 1,000 times the P hat, which was 0.662. Multiplying that, you should get 662. That is greater than 5. And then for the other one, 1,000 times Q hat. Haven't found that yet. Q hat is equal to 1 minus P hat. So 1 minus 0.662 which is 0.338. So when I multiply that, I get 338. So check and check. Everything works out for us pretty well for that one. Step 4, things that I still need in my life. I'm going to need to find the critical z-score for this one. So the confidence, or the level of confidence that I'm looking for from this problem, from what we highlighted up there, was 95%. So we can do our whole bell curve and find what half of it was and try to figure out, okay, well, where's 95%? Or we could remember that from 6.1, we had some time savers. And one of the time savers was that the z-score for 95% is 1.96. Always going to be that. So I'm going to use that time saver as much as I can. So that's given. Now, for the margin of error, and there's going to be problems where you just need to do this part, I'm going to just plug into my formula. So 1.96 times the square root of p hat times q hat. So 0.662 times 0.338 divided by n, and that's the number in your sample. So this is a wonderful calculator problem, and if you have your calculator, you can go ahead and take it out and check my work, or you can maybe just believe me that this is approximately 0.029. Not exactly, but approximately 0.029. Well, what else do I need in order to get this done? Now that I have my margin of error, I can kind of start setting up my whole entire confidence level. So this is the same thing that you've seen before, where you're going to have your p hat, which was 0.662 minus the margin of error, which was 0.029, is less than p and less than p hat, which is 0.662 plus the margin of error, so plus 0.029. Then you'll do a little bit of arithmetic and get that this is 0.633 less than p and less than 0.691. If they only ask you for the interval, then you could just write your regular interval notation. But this was a word problem. So in words, what I would like for you to say is, with 95% confidence, you can say that the population proportion of U.S. adults who say that it is acceptable to check email at work is between 63.3% and 69.1%. I'm going to write that out for you, but I wanted to read it first. So this is your sentence right here. If you want to press pause, go ahead and press pause so you can write that down. But with 95% confidence, one more time, you can say that the population proportion of U.S. adults who say that it is acceptable to check personal email while at work is between 63.3% and 69.9%. So that's just changing these decimal points into percentages. Okay, delightful. So this was a decimal point. This was a decimal point. All right, let's keep it pushing. Next thing that you all have is determining the minimum sample size. So we did this also with the previous lessons, and same concept, just a different formula. So in order to do this now, n is equal to p hat times q hat times quantity of z sub c over e, your margin of error squared. So you do have a couple of things that you should know. That the first part is that if the p hat is given, like the probability of success, then great, we can use it. But if it's not, then you're just going to assume that it's a 50-50 chance, like flipping a coin, 0.5 and 0.5. Again, if p hat is not given, then you'll just use 0.5 and 0.5. Given what I just said, I feel like you can kind of just do example number 2 on your own, but let's kind of just highlight a couple things together and make sure that you're okay. So reading the problem, go ahead and do that, and underline whatever you think is important. That's kind of what I see, and it's mostly because I'm going for the numbers part of this. So you want a 95% confidence in the portion that the proportion of registered voters who will vote for your candidate. So what else was important here? We want it within 3%. So that within 3% tells me that my margin of error, the E, let's go ahead and write it. E is equal to 0.03. Confidence Same confidence level as before. So I'm looking at Z of 95, and we said that it was 1.96. It's always going to be that. It's a nice time saver for us. So for part A, they want us to use this formula when no preliminary estimates are available. So that means we don't know P hat and we don't know Q hat. We'll use 0.5 for each of those. So N is 0.5 times 0.5 times 1.96 divided by E, which is 0.03 squared. Then you're going to use your wonderful handy dandy calculator and find that this number is 167.11. Now we will always round up to the nearest whole person or whole number. Always, always, always. So with that being said, we would need at least 1,068 voters. Okay, try the next one. You can go ahead, press pause, do that, and then I'll show you my work. Alright, so I did my work and I got 913.02, so we're always going to round up. I know it's really, really close to 913, but always round up. So you need at least 914 voters. Thank you so much and enjoy your day.